So online is it audible? Problem?
Yes, sir.
Okay, we'll go to, because there is a power failure here suddenly.
Okay.
Right now, so we'll work out again because. So what is our 10 diameter?
60 feet.
D is 60 feet. So project is not. Okay. Now shell, if you take shell settlement, the formula is D by 10. So D by 60 by, so formula is D by 10. That is 60 by 10. Then 6 is not allowed. We have to take minimum 8 readings. That is the one. Now if you go to the bottom settlement, there are two rules actually. One is you have to follow the D by 10 rule. So D by 10 is 6, but a minimum 8. But so if you draw this for bottom, 1, 2, 3, 4. So total we have, so 1, 2, 3, 4, 5, 6, 7, 8 set of reading. And each set bottom level, every 10 feet you have to take reading. Then, 10 feet. So what is the diameter here? 60 feet. So one row we will have 6 readings. Now how many we have? 4. This is 1, 2, 3, 4. So 6 into 4, we will have at least 34 readings. Or 24. Shit. Again readings. Okay, right.
Yes.
Yes, please.
No. Sir, 10 by 60 by 10 எப்படி சார் சொன்னீங்க?
D by 10 formula.
D by 10 எங்க சார் இருக்கு?
போன சாப்டர்ல இருந்துச்சு பாருங்க, சாப்டர் 8ல மினிமம் 32 feet.
D by
page number 12-9. N is equal to D by 10.
ஆமா சார். அதுபடி ஓகே சார். D by 10 வந்து மினிமம் 8 னால அது 8 போடுறோம் சார். இப்போ செகண்டுக்கு எப்படி சார் வந்து என்னன்னா அதுக்கும் D by 10 தானா சார் செகண்டுக்கு?
ஆமா, D by 10 தான், but we have to use every 10 feet. You see the sketch, annexure B sketch. You can see it here.
ஆமா சார்.
Every 10 feet you have to take maximum spacing of 10 feet across the diameter.
ஆமா சார், every 10 feet வந்து லைக் ஒரு ரீடிங் சார். அப்புறம் every 10 feetனா வந்து பாத்தீங்கன்னா லைக்
60 feet there will be 6 readings in one line.
ஆமாங்க சார்.
Total we are making 4 lines. 4 into 6 it will be 24. That's all. Okay. For because minimum 8 readings na 4 diametric lines. Okay.
4 diametric lines சார். ஆனா எப்படி மினிமம் 8 ரீடிங் சொல்றீங்க சார்? அது
திருப்பி சொல்றேன், 8க்கு கீழ அலௌட் கிடையாது, மினிமம் 8 வேணும்னு இங்க கொடுத்திருக்கான் பாருங்க. இந்த பாரு, மினிமம் 4 equally spaced. There must be at least 4 equally spaced வந்து diametric lines.
Okay sir.
Okay, right.
Thank you sir.
Right. Now we will go to the next one. Uniform settlement B-3. I think again there is some letters missing in this. Just to write it. Okay. Uniform settlement. B2.2 is uniform settlement. Uniform settlement. Uniform settlement of a tank does not include stresses in the tank structure. However, piping, tank nozzles and attachment must be given adequate consideration to prevent problems such as settlement. That is very important. Uniform settlement generally will not induce stress, but we have to piping, tank nozzle and attachment, we have to check carefully. Next one, rigid body tilting of a tank. Please write that, rigid body tilting of a tank. There are some words missing in the hard copy. Rigid body tilting of a tank. In bracket, it is a planar tilt. Planar tilt means you can see the sketch here. Tank is tilting one side. It is tilting like this. Okay. The component rotate the tank in a tilted plane. The tilt will cause an increase in the liquid level and therefore increase in the hoop stresses in the tank shell. Also, excessive tilting can cause binding and peripheral seals in a floating roof to inhibit the roof travel. This type of settlement could affect the tank nozzle that are piping attached. So it will inhibit the roof travel. So floating roof will be stuck. That is closed book question. So that is the rigid body tilting of the tank. Then next page, B223. Highlight this one. Due to the fact that a tank is rather flexible structure, the tank may be settled in a non-planar configuration. It will not settle uniformly everywhere. Some area may be settling on the shell, some area may be not settling. Inducing the additional stresses in the tank, the out-of-plane settlement of the shell can lead to out-of-roundness at the top of the shell, and depending on the extent of the induced out-of-roundness may impede the proper functioning of the float roof. Again, the out-of-roundness, the floating roof will be affected. That is open to question. Then these are not important. Please go to the next one, page number B-7, edge settlement. B-7, edge settlement. B2.3.1, edge settlement occurs when the tank shell settles sharply around the periphery, resulting in the deformation of the bottom plates. Bottom plate is bending. You can see the sketch here. So this is the edge settlement. This point is called a breakover point. So this is settling like this. It can either settle like this or you can set like this also. Okay. Now, how much edge settlement is allowed? Okay. So we have to take radius. R means from the where the breakover point to shell inside. Radius is always taken in feet. So radius means from the breakover point. This is the breakover point. From to shell radius. B is how much it can go down. B is taken in inches. There are two graphs we have to refer. One is where there is no joints in the bottom plate. Another one is bottom that annular plate joint. In that area, how much settlement is allowed? Where there is no annular plate joint, how much settlement is allowed? Just you will go to the, you can hear, we'll come back again. So please go to the page number B-13, B11, figure B11. Page number B-13, figure B11. You can see the bottom. Maximum allowable edge settlement for areas with the bottom lappets approximately parallel to that. That means that no perpendicular joint. Perpendicular joints will be the annular plate joint. Annular plate will be perpendicular to the shell. Where there is no annular joints, this is the graph you have to follow. For example, your tank diameter is say 100 feet. This is the tank diameter. And your radius of the settle area. You know what is the radius? I told you from the breakover point to shell. 3 feet. What is the maximum settlement allowed? 100 feet, 3 feet radius. How much is allowed? So where it cutting 100 feet 3? It is almost 3.5 inches allowed. You can see here. You have to see. You have to follow this 100 feet line. It is not 2.5. For 3 feet, it will be 3.5 something. 100 feet of follow up. 3.5 inch allowed. So what is the meaning of this? See, I just hold on. Hold this. I will go back. Suppose this radius is 3 feet. Tank diameter is 100 feet. What is the B dimension allowed is 3.5 inches allowed. Where it is allowed, where there is no annular joints. Annular plate will be a perpendicular joints. If you go to the next page, perpendicular, there is another graph. You can see figure B.12. Maximum allowable edge settlement areas with the bottom lappets approximately perpendicular to the shell. Now here same 100 feet, 3 feet, what is allowed here? (100 feet diameter, 3 feet, how much it is allowed? it is more than 4 point, say 4.2 or 3 like this. Okay. No, it's 4 point, not 4.6. This is the line you have to follow. It is very close to 4. Say it can be 4.2 or 4.6. Okay. No, இது ஆகலையா? Generate ஆனா? Okay. So 4.2 or 4.3. Okay. Right. Now, if you just read this paragraph above this, I will go to the paragraph B, page number B13. Please take page number B13, edge settlement. Again, I will repeat. Where there is no perpendicular weld, only parallel weld are there. How much allowed for 100 feet diameter, 3 feet, 3.5 inch allowed. Suppose it is, what is the acceptable limit? 3.5. Suppose it is not 3.5 inch, only 3 inches there. 3 inches acceptable, but there is another requirement. If it is the settled area is more than 75% of the 3.5. So if you take 3.5, 75%, how much it will be? 3.5, 75%. Into 75% divided by 100. Okay, so 2.6 inch. Suppose it is 3 inch, means what the code says, even though it is acceptable, because 3.5 is acceptable, but if it is more than 75% of 3.5, we have to do MTPT in the area to check for any cracks. So highlight this one, 3B 3.4.1. Maximum allowable settlement BEW for settled area that include bottom lappets essentially parallel. In settled area where the measured settlement exceeds 75% of the allowed settlement, all shelter bottom wells and bottom well should be examined visually and with the magnetic particle or liquid penetrant methods. All indications should be repaired on evaluated of risk brittle and fatigue failure prior to returning. So we have to repair it. Any defects, we have to repair it. Then next highlight B3 are the same. Maximum allowable settlement B is for area edges where no wells, butt wells or lap wells essentially perpendicular. That is next page graph. In settled area where the measurement settlement exceeds 75%, all shelter bottoms should be examined visually with MT or PT. All indications should be repaired. That's also important. Now we will go back where we left because we skipped some pages. So please go to the page number B-7. So highlight this sketch. This is the breakover point. Then page number B-10. There is another formula very rarely asked in the exam. Yeah, B.3.2.1. When using a procedure with the optimal Gaussian curve approach defined out of plane settlement, the perimeter, what is out of plane settlement allowed? S maximum feet L squared plus Y into 11 divided by 2 into E into H. So this is S max, all these things. We will do one calculation. What is annexure B? Just to hold on. So we'll calculate it. Okay, so calculate question number 6. Question number 6 using the formula. Using formula B3.2.1, determine the maximum permissible deflection out of plane distortion for a tank with the following data. Is it? 29 Young's modulus on it will be a 29 into 10 to the power 6. It's not 29,000, 29,000,000,000. That is the formula and calculate it. That's all. What answer you are getting? Hmm? You are not getting answer. See, what is the formula? Formula is, okay, what is the formula? S max L squared plus Y into 11. Huh? This is the formula you have to use.
Sir,
What is the formula?
0.0029, sir.
L squared Y into 11. Let me work out. L squared Y into 11. L squared Y into 11 divided by 2 into EH. 2 into E into H. Okay. 2 multiply EH. Okay. Now, what is the L? So, L is equal to 31.4 feet. So, if you go to the formula, what is the L is given? L is the arc length in feet, so 31.4. So, L is equal to 31.4. So, L is equal to 31.4. Okay. 31.4 feet. And Y. What is Y here in the formula? So, Y is the yield strength PSI. So, if you go to the question, yield strength is 30,000 PSI. Okay, good. 30,000 PSI. And E. So, what is E in the formula? E is the Young's modulus in PSI. So, if you go to the question, E is equal to Young's modulus 2960. Okay. 29,000,000 PSI. And H. What is the H? H is the tank height in feet. So, what is the height here? 60 feet. 60 feet. H is the 60 feet. Okay, we will apply the formula. L squared 31.4 multiplied by 31.4 into yield strength 30,000 11 divided by 2 into 29,000,000 into H 60. This is the way you have to work it out. So you are getting 0.09. Okay. Yeah. So one more, so what 31.4 multiplied by 31.4 multiplied by 1000. 11.
0.0059, sir.
1 minute, let me check. Divided by 2 into 29 into 6. Zero 0.09, correct. You work it out. You have done some mistake. So answer is correct.
0.0059 வருது சார்.
இல்ல தப்பு, உங்களுக்கு கால்குலேஷன் போட்டு தப்பா போட்டுருக்கீங்க. திருப்பி ஒர்க் அவுட் பண்ணி பாருங்க.
சரிங்க சார்.
Okay, 0.091. Okay. So 6, what should be the answer? 6 should be A. Okay. 6 is B.
ஆமா சார், 0.059 சார். 0059.
Where we do mistake?
059 கூட இல்ல சார், 0059.
Where we do mistake? Okay. L square 31.4. 31.4. Okay, into Y 30,000 into 11. So answer we will get 325. Okay, 325 366 800 divided by, okay, E into H we will 29,000 60 2960 multiply by 60, again multiply by 2. So we will get 3480 000 000. Okay, 325 366 800 divided by 3480. 0.09 only correct. No, I think question answer we will correct it already. Answer, this is I am using the old version which I have, but I already corrected it. This is the correct answer. Yeah, you can check it. That is corrected. You check your question bank. I think I corrected. Because I didn't correct in my soft copy. எப்படி போட்டாலும் அதான் ஆன்சர். Annexure B question number, as question number will be changed because one question we deleted, because this question there is a sketch is there. Yeah, I corrected it. Yes, I corrected it. I worked out and corrected it. Okay, there was some mistakes we corrected it. So state of answer is 0.09 only. Okay, right. So we will move on, but that is not very important. Go to the B-12. If measured out of plane settlement exceeds the applicable limits, a more rigorous evaluation may be performed to determine the criteria to determine the need of repair. That is important. Highlight this one. This is a closed book question. Suppose out of plane settlement they exceed limits, then a more rigorous evaluation performed to determine the need for repair. That line is important. Closed book question. Page number B-12. Bulging. Measured the bulge or depression. This is another very important closed book question. You have to remember this formula. Bulging allowed is 0.37 into R. So maximum depth in inches. B is we have to measure in answer will get inches. R is the radius in feet. R is the radius in feet. Okay. We have calculation. We will work it out later. Then this edge settlement B-13 already we highlighted it. Okay. So that's all. Annexure B. Okay, Annexure B will have 2 to 3 questions. That's all. Now we will go to the Annexure C. Checklist. See, checklist means there are 2 types of checklists. C1 is when the tank is in service. How to check the tank? It will start from the foundation, what you have to check like that. And the C2 is when the tank is out of service. Generally, there is one question asked in the open book. Suppose they are asking which of the following is not required to be checked in the tank foundation. Don't check that. You false. Answer is in the checklist. You can see checklist C1 in service checklist. So far exam asked in various exams. Concrete ring was asked in the open book question in one of the exam. Concrete ring was asked. It all we covered in your question bank based on the feedback. Then next page, tank pipe manifold was asked in one of the exam. So generally the question will be which of the following need not to be checked in the tank pipe manifold during in-service inspection. Then you have to check which one is not the answer, you have to choose it. Yeah. Then next one, so only two there was asked in the various exams. If you go to the C2, page number C-8, tank out of service inspection checklist. So again, this was asked in one of the exam. Emergency pressure vent hatches C2.7.4. That is open book question. That's all. Then one more, shell man nozzles C211.3, page number C-14, last one. Shell nozzle, which you have to check. That also highlighted. Shell nozzles C211.3. Okay. So the answer was inspect hot tap nozzle for trimming of hole. Yeah. Then annexure D, nothing is important. Now D2, go to the annexure D2, page number D2. Every 3 years, you have to renew your API certificates. So in the 3-year period, you should give evidence that you are continuously working in the tank inspection for at least 20% of the time. Or you are actively, that is called actively engaged, or inspection of 75 storage tank logbook. Just to highlight it, it is not important. The actively engaged as an authorized inspector shall be described as one of the following: minimum 20% of the time spent performing inspection activities, supervision, inspection, or engineering support in the over the most recent 3-year certification, performance of inspection of 75 storage tanks. Now, annexure F. Annexure F may be helpful during your exam. So it says where the NDT chapters are there in code book. For example, if you take VE, visual examination, it is covered in 6.312, chapter 12, 1.22. If you do MTPT, suppose you want to locate some NDT methods, you can check here and you can click here also, directly it will go. Okay. Yeah, reference. Now we will go to the annexure G. Again, there will be 1 or 2 questions from the annexure G. What is annexure G? How to qualify the MFL personnel? Bottom scan. There are 4 points are important. First, they should be given training for at least 40 hours. The MFL operator should be given training at least for 40 hours. It is closed book question. Second one, how to test them? We should have a 70 square feet plate. 70 square feet means 10 feet by 7 feet. 10 feet length, 7 feet width, 70 square feet, which will have underside pits and overside pits, closed pits. So they have to use a MFL machine and to find out the pits. Okay, they find out the pits and the corrosion. Okay. So what is the length of the dimension of the test plate? 70 square feet. That is the closed book question. Now, third one is when they will be disqualified. If you are not scanning MFL for 6 months, they will be disqualified from the certificate. The certification will be revoked. Or a particular procedure they are not using more than 1 year, they will be disqualified from the particular procedure, or they change the company, their certificate will be disqualified. You have to prepare, you have to again qualify, because one company certificate, other company cannot be used. Then who is responsible for the qualification of this person's authorized inspection agency? They have to qualify them. These 4 are closed book question. There are open book based on the thickness of the plate, actual tank bottom thickness, how much thickness, how many pits we have to put during the testing, and how many percentage they have to define. These are the open book questions. Generally, there will be 2 questions will be there. Okay, so please, these are not important. Directly go to the page number G3. G3, tank bottom examiner, page number G3. Highlight the G4.3. Each authorized inspection agency is responsible to train, test, and qualify the scanning operators and examiner they employ using the follow-up techniques. Qualification gained through one authorized inspection agency are not necessary valid for any other authorized inspection agency. So only valid for one inspection agency. That is a closed book question. G4.4, the authorized inspection agency is responsible for training each scanning operator they employ. Each scanning operator should receive a minimum 40 hours of training. That is a closed book question. Then G4.5, the authorized inspection responsible for testing each scanning operator by written examination. This test question should be appropriate for a scanning method to be used. The authorized inspection should establish the passing score. Then next page, G4.9, this is important. Again, the bottom scanning examiner, operator, or UT examiner should be requalified when any of the following apply. A, when the examiner is not qualified with the procedure. B, when the authorized inspection agency changes the procedure. TB means a tank bottom procedure. C is important, when the operator has not performed a tank bottom scan for 6 months. If you're not scanning 6 months, he will be disqualified. Then D, when the operator is not used the specific procedure for 12 months. That also important, close the question. Then E, when the authorized inspection has a reason to question the ability of the examiner. Suppose he is not capable, then he will be disqualified. Then F, when the examiner changes the new authorized inspection agency, that user for the essential variable that are. And G5.1, again close book question. The qualification test will be performed as a sample tank bottom. The sample tank bottom should be minimum 70 square feet. That is a close book question. Then what is the minimum number of type underside pits? Again, there is a mistake in the hard copy. Please write this one. Less than T, less than, there is a T missing everywhere. T less than 0.05. What is 0.050? 1.3 mm. We should have minimum 2 pits. Write this in the hard copies. 0.05 to T less than half of the capital thickness, original thickness. Capital T is the original thickness. We should have minimum 5. When half T is greater than half of the thickness, but less than 2/3 of the thickness, we should have minimum 4. Please write this in your this one book. Mistake missing the T எல்லாம் miss ஆயிருக்கு. This is open book question. So how many you should have the underside pits when the thickness, actual thickness of the bottom plate is less than 1.3 mm, 0.05, we should have 2 pits. When the actual thickness is more than 1.3 meter, but less than half of the original thickness, we should have 5 pits. When the thickness is between up to 2/3 of the original thickness, we should have 4 pits. That is the meaning of this. Now, how many pits for testing we should give for the examiner? We should have in the test plate at least 5 pits underside. Yeah, qualification. This is the qualification test plate you can see here. The next one, how many percentage you have to find out? You can see here. This is the product side pit. Top side, how many pits? Whatever the thickness, there will be 2 pits. Thickness is 0.05 to half T or half T to 2/3. We have to have top side all only 2 pits we should have. Which one? Yeah. Okay. Yeah, that's correct. Then how much percentage required to evaluate? Suppose if the thickness is less than 0.05, he should be able to find out 90% to 100% of the pits. Open book question, this table. 0.05 to half T, 70 to 90%, half T 40 to 60%. General correction, you have to find 100%. That's all this one. Then we'll go to the similar service assessment. Again, there will be 2 questions. 1 or 2 questions will be asked similar service assessment. Understand this concept. What is meant by similar service assessment? What is similar service assessment? Suppose in a particular area, say we have 5 tanks. So only one tank we will do complete internal inspection. That tank is called as a control tank. Other tanks are called as a candidate tank. Candidate tanks means for which we will not do internal inspection. We will not empty the tank. We will do on stream. On stream means checking outside by using UT, NDT methods. So the control tank where we have a complete history with the internal inspection, everything. So that will take as a reference for the control tank. Now, if all the tanks are constructed in a same year, same material, storing a same product, the exercise is very simple. One is everything will follow. But if they storing a same product but constructed in different years, so for a year we have to give some correction. Suppose they are storing different products, we have to rate which one they equal to which product. These are called similar service assessment. The concept is so you can equalize everything. Everything there will be a correction. Year of erection there will be a correction. How many years changes? Because correction rate will change. Year of year, material, which material? The tank material is differing. Operating conditions, temperature differing, stored products. So generally there will be one or sometimes 2 questions. So highlight this one, similar service assessment. Again, there will be some mistakes. So highlight this one. I copy now. I give you a new edition actually from the other book. Old edition we copy and paste it for the soft copy because there is a many mistakes here. So highlight this one. This annexure intended use by an authorized inspector, storage tank engineer, and other person having knowledge and experience in the performing similar service. So who will conduct the similar service assessment? Authorized inspector, storage tank engineer, and other person. There mistake soft copy you can correct it. Then highlight the H2 third line. Similar service assessments is conducted using design, construction, operation, maintenance, and inspection data. Data should be obtained using direct or indirect examination such as MT and PT, evaluating product corrosivity, measuring cathodic protection level, determining spoils properties, and other factors. Everything we should consider. Then what are the additional assessment you will use? First, year of tank character. So when the year of tank character is the missing area. Okay, just write it. Year tank H2.1.1. Year tank character. Highlight the B if it is there. Any substantive difference in the design and the construction standard which the tanks were erected must be considered in the similar survey. That is open to question. Then H2.1.2 bottom material. H2.1.2 bottom material. Then H2.1.3 shell material. 2.1.3 shell material. H2.1.1 corrosion allowance. Yeah, please write this. Yeah. H2.1.3 bottom lining thickness age. H2.1.6 cathodic protection. Is it okay? These are not important. Okay, but then these are not important. Leave it. You can have the soft copy. There's no problem. Okay, now just to go to this one, this table is important. H3.2 similar service product classification. This table regularly they are asking. For example, class A, it is low sulfur light oil less than 1% is equivalent to. These are considered as a similar service. Number 2, fuel oil, diesel, kerosene, jet fuel, gasoline. These all are considered equal to the low sulfur light oil. So exam they asked about the finished lube oil, which was asked in one of the exam. Finished lube oil, which is the similar services, automotive, diesel, and aviation. These are similar services. Huh? Similar services on the table of if the different product are stored. That's all. 653.
Sir, sir.
Yes, please.
Sir, in previous chapters, section G, you were mentioning about the number of pitting in the bottom of the test piece. Is there anything minimum number of? I think G 5.1.3, sir.
Okay.
Reminding it was like so quick, I couldn't follow it, sir. So is a number of pitting on the bottom shell, or what was that, sir?
It is a bottom plate. Scanning we are using for bottom plate only, not bottom shell.
Yeah, bottom plate. So the number of pitting for the test piece.
For testing, test piece. Yep. Top side, this is the product side, there should be 2 pits at least. This is the minimum number of pits. You can have more than this for testing.
Okay.
And bottom, pit on the top side, that is product side, at least 2 pits you should have.
Okay.
Whatever the thickness. And the top side, the bottom side means underside.
Yes.
Okay. We should have based on the thickness. If the thickness is less than 0.05 inch, actual bottom thickness, testing plate should have at least 2 pits.
Sir, in annexure H, figure H.2 is not important?
Not important, right?
So need not to look after it. Huh?
Yeah, no need to look after. Only the table is important. Okay, Sriram, this is the one. This is the number.
Okay, sir. Okay, sir.
Okay.
Thank you, sir.
Okay, this is the end of 653. So 653 generally will have around 80 questions. Okay. So we have almost 1 hour left. So we will start 571. Please take 571 damage mechanism. 7-1. ஆமா ஏன்னா இல்ல 6 பாயிண்ட் 60 ஃபீட் தானே டயா 10 ஃபீட்டுக்கு வரும்னா 60 ஃபீட்டுக்கு 6 பாயிண்ட் தானே ஆமா அங்கிட்ட போனோம் ரைட் சரி this okay damage mechanism 571 which edition they followed 2020 okay yes 2 minutes break you can have a break then we will continue. What happened?
Sir, from 653 annexures, 53 annexures, how many questions we can expect?
Say annexure B, all annexures you are asking or generally?
Yeah, all annexures.
Annexure generally will have around 6 questions. Annexure B is a very important, will have around 3 questions, 3 to 3 questions. Annexure H may be 1 or 2 questions and annexure C may be 1 question.
And all other this supplementary codes 571, 578 and all, no? From those codes, how many questions we can?
571 will have around 10 to 15 questions. That is important. 578 will have only, maybe 578 will have only 1 question like this. Okay, we will cover it. 571 we have already. No, I don't think 5. No, we don't have 578. 576 may be only 1 question. Because only
Actually,
two chapters are there.
Sir, actually, during the time of Phyton examination, I had given
Phyton is
the
different.
yeah,
Phyton is
yeah.
different.
Let me tell.
Yeah.
I have given the importance to Phyton and the other section 9
Okay.
and section 5.
Okay.
These all are codes I did not went through that much. I did not put the time on this much.
Okay.
As in the exam, the most of the questions came from the main subject only.
Yeah, but it is not like that because they are using different set of questions.
Mm-hmm.
That's why we are giving equal importance to most of the codes.
Mm-hmm.
Okay, because every time they are revising the questions. Okay, if you go with particularly only focusing 653, if you are lucky enough, you will get to most of the question from 653. Sometimes they ask the question from 571 or 575. Then some need not to struggle. That's why we will cover everything. Okay. Because they are using almost 10 set of questions in each exam. Some sets are very old. Old sets have a old set pattern. It is like that. 653 will have more than 85 to 90 questions. Old set. 650 will have around 20 questions. 571 will have around 10 to 15 questions. 575 around 8 questions. That is old. But every time they are changing the pattern little bit. Some new sets will have more questions from 575 and 5 this one. So that's why we will cover little elaborate.
What's the minimum number of questions from 653, sir?
There is no rule like this.
Like a percentage wise?
Percentage wise, it should be around 50%, at least 40%. 653.
That's very less.
That's okay. But it will not go more than 60%.
It won't go more than 50%.
Yeah, it will not go more than 60%. 653 is asked. Maximum they will ask 60% question. Minimum at least 40% question will be 653.
Remaining questions from
don't just focus. See, main codes are 650 actually not a very important code. But we took 650 more than 2 days because if you understand 650 only, you can understand 653. 653 is the most important code. If you ask 650 would be took 2 days. Almost more than 2 days, I think. That will be only 20 questions asked. 571 I am going to cover in 2 hours. That also will have 15 questions. 571 I will take maximum 3 hours. It will also have 15 questions. That 650 is not very important. But the problem is, if you don't understand 650, it is very difficult to understand 650. Okay. So that's why because of 650 only, I told you, even construction now, tank construction, they are asking 653 certification because it is a reality that people have 653 certificate will have knowledge of 650. So we almost gone through most of the chapters in 650, except the annexures. Okay. Right. Let us go to the 571. 571 will have around 10 to 15 questions. Okay. But for you, only 11 damage mechanism. Actually, 510, 570 exams, 571, they are giving more importance. They are now asking more than 20 questions in 510, 570 exams. But 653 exam, they are asking the range is between 10 to 15. First, which are the things you have to understand? Terms and definitions. I will go through just a little bit class like that. Then we will go through the code. First, what is steel? A simple basic question. What is steel? So it is the alloy of iron plus carbon. Iron plus carbon, because iron, we have a chemical symbol, Fe. Iron is an element. But pure iron, generally, we are not using in the industry. The problem with iron is, it is cheap. The advantage, it is cheap, plenty available. But the problem is, it does not have much strength. It is soft. Okay, and the lack of ductility also not there. To improve these properties, we are adding carbon. Even though carbon is alloy, but we will not call the steel as a alloy steel. Alloy steel will have different meaning. Alloy steel means other than carbon, chromium, molybdenum, vanadium only we call it as a alloy steel. Generally, steel we will call it as a steel, or sometimes it is called mild steel. Sometimes we call the low carbon steel, medium carbon steel, high carbon steel, like this. Okay. Now, this is about the steel. Next one is, what are the other alloying elements? Steel generally will have chromium. What is the purpose of adding chromium? For corrosion resistance and and for improving the toughness. So chromium is corrosion resistant and strength. Nickel to improve the toughness. Molybdenum to improve the creep resistant, high temperatures. So these are called alloying elements. If the alloying is more than less than 9%, as per 571, they are called as a low alloy steels. So what is the limit for low alloy steel? Alloying elements other than carbon should be up to 9%. If it is more than 9%, we call it as a high alloy. Okay. There is another set of steel called HSLA steels, high strength low alloy steels. So what is HSLA steels will have niobium, vanadium, titanium less than 0.1%. Okay, and the next set of steel is called stainless steel. We have 4 types of stainless steel. Stainless steel generally will have a chromium and nickel. They may have other elements also. So what are the 4 types of stainless steel? Austenitic stainless steel. How will you identify the austenitic stainless steel? 300 series, 304, 316, 321, 347. Sometimes you will have a L grade and H grade of stainless steel, 304L, 304H. What is L and H? Low and high carbon. It was asked in one of the AP exam, closed book question. What is L and H means in the stainless steel? Low and high carbon. Next one is called ferritic stainless steel. They are 400 series. Third one is martensitic stainless steel. They are also 400 series. Fourth one is called duplex stainless steel, which will have ferritic and austenitic structure. They are 2000 series. Alloy 2205 like this. They will have 2205, 2304. They will have a 4-digit number. Another set of materials are called nickel-based alloys. Nickel-based alloys plays an important role in damage mechanism. Because the advantage of nickel-based alloys is they are resistant to many of the damaging mechanisms. They are resistant materials. They will withstand this. So what is meant by nickel-based alloy? This is a closed book question asked in one of the AP exam. When the nickel percentage is more than 30, they are considered nickel-based alloys. Nickel alloys contain nickel more than 30%. Okay. How you will identify the nickel-based alloys? Alloy, a 3-digit number. Alloy 200, alloy 400, alloy 600, alloy 627. Alloy, a 3-digit number, is considered as a nickel. Okay. These are the things we should know in the terms and definition. Now, come to the damage mechanism. So storage and the advantage is generally they are not operating with high pressure. They are not operating with very high temperature or very low temperature. So many damage mechanisms actually given here is even though not related to tanks. Okay, generally they are thinking this 11 damage mechanisms can affect the tank. If you take the damage mechanism, what are the atmospheric corrosion, brittle fracture, caustic corrosion, stress corrosion cracking, chloride, CUI, mechanical fatigue, MIC, soil corrosion, sour water corrosion, sulfuric. So first I will start with the damage mechanism affecting outside of the tank. So what are the external corrosion damage mechanism? Atmospheric, 1. These are the internal one, chloride, CUI, this is outside, 2. Then soil, these 3 are the outside corrosion. Okay, so let us complete terms and definition, then we will go to the this 3, then we will go to the internal corrosion, then other mechanisms. So please take first terms and definition. Okay, right. Highlight the austenitic stainless steel, which is in 2.212. So the 300 series 3.4L, this is important close book. The L and H suffix refer to control ranges of low and high carbon content. Then duplex, highlight 2.1.6. A family of steel contain mixed austenitic and stricter. Then ferritic stainless steel, highlight this family of steel including 400 series. Highlight the HSLA steel, high strength, low alloy. Yeah. A family of carbon steel, higher strength achieved by the addition of moderate amounts of such as titanium, vanadium, niobium. Then low alloy steel, a family of steel containing up to 9% chromium and other alloying elements. Then martensitic stainless steel. You will change it.
A little bit slower, sir. Can you scroll it forward, sir, please?
These are not very important. That's why I'm just going fast.
Okay, sir. Thank you, sir.
Low alloy steel, so containing up to 9% chromium. Then martensitic, so this is the again 400 series. Family of steel including 410, 416, 420. Okay. Next, this is important. Nickel based alloys. What is meant by nickel based alloys? A family of containing major alloying greater than 30%. 200 alloy. See, I told alloy with the 3-digit number: 200, 400, 500, 800, 600, 600H. All these things. Then finally, what is meant by stainless steel? The alloy of iron with at least 10.5 chromium plus other alloying elements depending on the specific grade. So generally, they will have the low. Now, know some abbreviations. What is ACFM? Yeah, highlight this one. See, ACFM is alternate current field measurement. Then just to highlight it, what is AET? Acoustic emission testing. Then what is AUBT? Automated ultrasonic backscatter testing. It was asked, actually it is not important for tank, it is asked in the Python exam. Because Python, AUBT, automated ultrasonic backscatter. Yeah, Python. Now, let us start with, I told first, atmospheric corrosion. First, you have to understand the damage mechanism, because I told you this is one of the easiest scoring possible in this code book. If you understand properly in the class, you can get 10 to 15 marks. Okay, first, what is meant by damage mechanism? Damage mechanism, deterioration, all are same. When you are going for inspection, you should know what you are looking for and where the problem will come, which NDT will detect, how to avoid it, what is the corrective action. So first, if you see outside the tank, atmospheric corrosion may come. What is meant by atmospheric corrosion? Corrosion caused by atmospheric condition. Atmospheric, for example, I have a storage tank in here. This is a Trichy. It is a rural area. But if you have another tank with Chennai, Chennai is the marine environment. The external corrosion, atmospheric corrosion in Chennai will be more because there is a seashore near marine environment. So atmospheric corrosion depends on the location. Point number 1. So which location will have more atmospheric corrosion? Marine environments and polluted industrial environments. If you have pollution, industry pollution, which will have sulfur, the pollution will have sulfur, it can cause more atmospheric corrosion. Please remember, even if it is a marine environment or industry environment, if the tank is properly coated, there will be no atmospheric corrosion. So atmospheric corrosion will affect only tanks which are not coated or there is a coating failure. It is coated, but it is not properly done. There is a failure. That only it will affect. Is it clear? So atmospheric corrosion, where because of the atmospheric condition, moisture and other salt content with the atmosphere. Next one, which material it affects? Carbon steel it will affect. Low alloy steel it will affect. Then copper alloyed aluminum also affected by the atmospheric corrosion. This is the open book question. No problem. Generally, stainless steel are not affected by atmospheric corrosion. Third one, what are the critical factors for the atmospheric corrosion? The location. I told whether it's a marine environment or polluted industrial environments will have more corrosion. Dry rural environments will have less corrosion. Now, how much the corrosion rate? Corrosion rate generally we are using 2 units, inch per year or mils per year. Mils per year means how to convert inch to mil? Multiply by 1000. We have to multiply by 1000. Marine environments, if it is not painted or painting failure, it can corrode 20 mils per year. 20 mils means half millimeter. 40 mils is equal to 1 millimeter. So marine environments can cause a atmospheric corrosion 20 mils per year. Wet rural polluted industrial will be 5 to 10 mils per year. You have to remember this value. Wet rural will have 1 to 3 mils per year. Dry rural will have less than 1 mil per year. It will not have a very low, it will have a very low percentage. Another important is, I will just say key point, then we will go through the project. Temperature and corrosion rate are always related. When the temperature increases, corrosion rate also will increase. It depends on the storing temperature or atmospheric temperature, but it will be up to 250 degrees Fahrenheit only. When the inside storing product temperature is more than 250, there will be no atmosphere, what you call the moisture on the surface. It will dry the moisture immediately. The atmospheric corrosion will not increase. So up to 250, it will increase. 250 degree Fahrenheit means approximately 110 degrees centigrade like this. Another one is, that's about the atmospheric corrosion. Now, how the appearance will be? How the appearance will be atmospheric corrosion? Generally, it may be uniform, or sometimes moisture are there, it can be localized corrosion also. Then how to prevent atmospheric corrosion? I told you we cannot change the atmosphere. So you have to proper surface preparation and coating application. NDT, there is no special NDT because we can check visually if it is corroding, or if you want to go for, you can go for the thickness measurement by UT. Nozzles, we can do radiography also. Radiography, profile radiography to measure the thickness. These are the key points you should know about the atmospheric corrosion. Any questions, please? Is it okay? So please take highlight this. Corrosion that occurs from the moisture associated with the atmospheric condition, marine environment, and moist polluted industrial environments with airborne contaminants are most severe. Dry rural environment cause very little corrosion. That is closed book question. Mark it because generally 571, wherever our marking there, from there only question will come. Affected material is the open book question. Carbon steel, low alloy steel, and copper alloyed aluminum. That is a open book question. Critical factors, highlight this one. The physical location of the plant, the amount of moisture typically presence, then presence of salts. Then this is important, regularly asked the closed book question. Corrosion rate increase with the temperature up to about 250. Above 250 surface are usually too dry for corrosion to occur except under insulation. Up to 250 only corrosion rate will increase. Then H is important. Marine environments can be very corrosive, about 20 mils per year. You have to remember this value. These are closed book questions. As are the industrial environment that contain acid or sulfur compound, 5 to 10. Then inland location, moderate amount of humidity, 1 to 3. Dry rural will have very low corrosion rate, less than 1 mils per year. These all are important. Closed book question. You have to remember this value. Affected units, highlight this one. Unpainted, uninsulated, carbon steel and low alloy steel equipment operating below 250. These are the conditions for the atmospheric. It should be unpainted, uninsulated, carbon steel, low alloy operating below 250. Then C, equipment downwind of the cooling towers and anything near the cooling tower, because there will be a continuous mist, moisture, it can corrode. Then go to the next page, appearance. The attack will be general or localized depending upon the condition of the coating and any whether the moisture is trapped. Then C, localized coating failures will promote the localized corrosion. Prevention, very important. Surface preparation and poor proper coating application are critical for long-term protection in corrosive environment. So we have to prepare surface and proper coating application. Then UT, inspection UT, these are not a straight beam, angle beam, eddy current also we can use. Not important, these are not important. So how many questions we marked here? Prevention, surface preparation and proper 1, 2, 3, 4, 5, 6, 7. So 7 question areas, these are important for exam. Generally, maybe 1 question. Some damage mechanism will have 1, some damage mechanism will have more than 1 question. Is it okay? Atmospheric corrosion. The next one we will go CUI, corrosion under insulation. I am not going in the alphabetical order. So just I will So you can page number I will say. Page number 111. COI. Okay. COI is a very big damage mechanism actually. Okay. Another very important damage mechanism. Now, I will briefly explain, then we'll go. What is meant by CUI? Again, when the insulated tank, when the insulation become wet and it is in contact with the tank, the wet insulation, if it is contact with the tank, which is not painted or paint fails, it can corrode your tank. Very simple. So for CUI in the tanks, it is applicable to, it is a common code actually, applicable to piping, pressure vessel, everything. We need 3 conditions. The insulation should be in wet condition. Second condition, that it should be directly in contact with the tank or vessel. Third condition, the tank or vessel should not have coating or the coating failures. If these 3 conditions exist, there will be a CUI. Point number 1. The 4th condition, that is called what is the operating temperature of the equipment. Generally, CUI will happen apart from these 3 conditions. So what are the 3 conditions? Wet insulation, painted, unpainted or paint failed, and the direct contact. And the 4th one is the temperature of the tank or vessel. This temperature you have to remember. Carbon steel and low alloy steel, it will happen only 10 to 350 degree Fahrenheit. Astatic stainless steel 140 to 350 degree Fahrenheit. Duplex stainless steel 280 to 350 degree Fahrenheit. Upper limit is 350. Lower limit to say everything, whether it is a carbon steel, low alloy steel, austenitic stainless steel, duplex stainless steel, only up to 350 CI problem will be there. Because more than 350, the insulation immediately dry, even it becomes wet because of the high temperature. Lower limit, carbon steel, low alloy steel 10 to 350. Austenitic stainless steel, I told you, 140 to 350, duplex 280 to 350, very, very important. Almost most of the exams in any AP exam will have this question. Temperature range for the CUI. Is it clear? Now, what is the definition of CUI? Corrosion under insulation caused by wet insulation. That is the reason. Okay. Then what are the critical factors? I told material. Temperature, I told. The temperature is the critical factor. Now, which insulation become wet? When insulation become wet, rainwater entering the insulation. When rainwater will enter the insulation, if there is a break in the insulation sheeting, insulation covering, there is a break. Where there is a possible for the break in the tank, wherever nozzle areas, ladder clip area, where if it is not properly cocked means not properly sealed, then water can enter. Or if there is a leakage in the tank, insulation can become wet. If you take piping leakage, steam tracing leakage, and the pipe vent drain, these are the, and any tank located downstream of the cooling towers. There is a big list. These are the possible areas of the CUI. These are the critical factors. Now the next one, which material it will affect? Carbon steel, low alloy steel, austenitic stainless steel, duplex stainless. Temperature I already told you. Then how the appearance will be? So atmospheric corrosion, I told you, generally it will be uniform, sometimes localized. Whereas CUI will be generally localized, sometimes it can have a pitting appearance also. Pitting means dent, small spot. But in stainless steel, it can be a chloride stress corrosion cracking, very, very important for exam. Because we have a separate damage mechanism, chloride stress corrosion cracking. Chloride stress corrosion cracking, we need 2 conditions. 3. Yes, austenitic stainless steel, yeah, chlorine, wet chlorine, and a temperature more than 140. These 3 conditions exist, then it will be a stress corrosion cracking. Stainless steel, I told you what is the acceptable temperature, stainless steel 140 to 350. So temperature is there. Generally, insulation will have a chlorine. When they become wet, when they in contact with the stainless steel, they promote a chloride stress corrosion cracking. So generally, CUI will appear as a localized corrosion or pitting, but austenitic stainless steel, it may be a chloride stress corrosion cracking. Appearance I told. How to prevent it? So tell me how to prevent CUI. We have to eliminate one by one. First thing, we should use a insulation which will not wet, which will not absorb moisture. The absorb moisture is called a wicking action. WICKING, wicking. So there are special insulations are there, closed self-foam glass insulation. We can go for it, but that is not very easy because they are very expensive actually. The best option is maintain a barrier between insulation and the tank. It's the insulation, even it become wet, should not touch the tank. How will maintain a barrier? Use a aluminum spray paint on carbon steel tanks before insulation. Why they are using aluminum spray paint? Because aluminum will corrode preferentially over steel by there is called galvanic corrosion. There is one corrosion called galvanic corrosion. That is cathodic protection basic. Aluminum will corrode, protect the steel. Or stainless steel, we can use the aluminum foil and insulate it. Okay, these are the how to prevent it. Then next, which NDT will detect? Here we have two types of NDT. One is to check insulation is wet or not. Which NDT will detect insulation is wet or not? எந்த NDT insulation wet or not? You have to measure the temperature actually. Infrared thermography, a non-contact temperature measuring technique. There is one more technique is called a neutron backscatter. That is advanced NDT which can measure the temperature. So neutron backscatter or infrared thermography will check whether the insulation is wet or not. But how you will check? Remove the insulation and check. One, without removing insulation also there are other NDT techniques. Deep penetrating eddy current. These are, you might have not heard this one. Deep penetrating eddy current, we can measure the thickness with the insulation. Okay, and even nozzles, I told profile radial glass. Without insulation, removing insulation also we can measure. So these are the key points about the CUI. So please take description of the damage, corrosion of piping, pressure vessel and structural component resulting from water trapped under insulation or fireproofing. Then affected carbon steel, low alloy steel 300, 400 and duplex. That is important. The next one, temperature, duration, these are not important. This is highlight open book. Corrosion rate increase with increasing metal temperature up to the point where the water evaporates quickly. That is important, open book question. Then these three are important. In most situations, refinery generally focus CA management, carbon steel, low alloy steel and 400 series 10 to 350. For 300 series, chloride is concerned and focus 140 to 350. For duplex, where chloride is the concern, 300 is there, 140 to 350. 300 series, see, carbon steel, low alloy steel 400 to 10 to 350. 300 series 140 to 350. Duplex stainless steel 280 to 350. These are important. Then C, poor design and installation of insulation system that allow water to become will increase the CUI. That line is important. Then D, insulating material that wick moisture and can hold water and more prone to causing extensive CUI. That is important. Close book question. Then highlight the G. Equipment that operates below water dew point tend to condense water, thus providing a wet environment. Then I, plants located where high annual rainfall and warmer marine are more prone to CUI. Then please go to the next page. 3. Piping components and locations that are particularly susceptible include dead legs, vent drains and pipe camber, walls, fitting, irregular insertion, bolted in pipe shoes, steam tracing, the termination of vertical pipe, all these things. These are open book questions. Piping and equipment that damaged and leaking tracing is susceptible. Then 11, where piping and equipment have been coated beneath insulation, local CAs can still occur where the coating has notorious damage. So even though it is coated, if there is a coating damage, still there is a possibility of COA. An appearance, carbon shield and lower lash are subject to corrosion having a rough, uneven, somewhat pitted appearance, usually covered with a loose, flaky, non-protective scale attached. The corrosion will be localized to wherever the metal has been kept by the insulation. Then C is important, closed book question. 300 series subject to SCC, stress corrosion cracking, if chlorides are present, while the duplex stainless steel are less acceptable. Then prevention. Since most construction material used in refinery are susceptible to COI, mitigation is best achieved by appropriate coating to the equipment prior to insulating. That is important. We have to properly coat the equipment. Then this is open to question. Flame sprayed aluminum coatings have been used on carbon steel. The coating corrodes preferentially by galvanic, thereby protecting the base. Then highlight the C. The aluminum foil wrapped on stainless steel, a piping and equipment can provide an effective barrier due to the galvanic effect of the aluminum. Then F. Low chloride insulation should be used on 300 series to minimize the potential for pitting and chloride stress corrosion cracking. Then highlight the one. Some manufacturers supply insulation certified to be low chloride. Thermal insulation can be tested ASTM C871. That is important. Open to question. Then highlight the G. Insulation plugs removed for UT thickness measurement should be promptly replaced and sealed. Several types of removal plugs that permit insulation and identification are commercially available. Then please go to the next page. Page number 114. So how to wear the ND technique? GWT, guided wave testing. Guided wave testing is a long range UT. Both are same. I will show a video if I have time. Yes. RT, including profile, density, radiography, profile, all we can use. Open to question. PEC is pulsed eddy current, and a Newton back canter for identifying wet insulation, and infrared thermography also wet insulation. So how many questions? 1, 2.
Sir, what do you mean by GWT?
Guided wave testing. That is called long range ultrasonic testing. Yes.
Sir, one more question. What is the difference between painting and coating? There it is saying coating.
No, the coating is coating is only for corrosion protection. Painting is for corrosion protection as well as appearance.
Okay.
We are painting our houses.
Yeah.
That is not for corrosion, that is for appearance. Coating is only for corrosion protection. Okay. Okay, I forget the number. How many now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 questions. Now, how many of you know what is guided wave testing or LRUT? Wave testing, GWT. It's not PAUT. So what is LRUT?
Sir?
Yes, please.
Yeah, I have question, please, because our body of knowledge starting from 427 to 5111. I mean, now from first until fourth, it will be coming in our exam or no? Because we have re-exam.
Which one? From body of knowledge we are talking about.
Yeah,
that?
body of knowledge. What I follow exactly 427. What I have the last exam exactly in last August. Okay, but and from 427 until section 5111. I mean, full it will be coming or no? Because and exactly a lot of things is different than what I have the book hard copy. I use what I have the last for August exam. But what
No,
you have
no
now,
problem.
the additional 20.
No, 1 minute, 1 minute, 1
Okay.
minute, 1 minute. Just hold on. I will open the body of knowledge. Okay, so this is a body of knowledge which I'm displaying you now body of knowledge, right? Okay, what is your exact question? Hello?
Yes,
So what is your question?
exactly, because in exam exactly we're going to follow the body of knowledge. What body of knowledge you give it, we follow on that one. Or
Yeah, you will see. Our class will be based on the body of knowledge only.
okay, but I mean, that's my question exactly. It will be because I need to focus more for full 571 or only what we give it in body of knowledge.
No,
For
what
my
will
exam.
give it in? No, what will only for what will give in for body of knowledge only. If you see body
Yeah,
of
because
knowledge,
if
only this 11
body of
damage.
knowledge exactly.
Yeah. No need to focus on other 571. Only question based on this 11.
And also, and one question more exactly, because my exam in last August. I mean,
Okay.
now in March, it will be, I mean, 21 March, I have the re-exam. I mean,
Okay.
it will be changed in question and or scope, an exam scope, or it will be same? Because
See, last August, that effective sheet was different. This is the effective sheet which came to in November only, November 2021. What is the change is 571, it is 2020 revision now.
revision, okay, but
Yeah,
mean,
yeah, 570 we have 2020. 575 also we have 2020 revision.
okay.
And
Mean it will be
another
coming this one.
577 also we have 2020 revision, which we will take class based on this effective sheet only.
And the exam it will be coming based
This
the
one only, this one only, this one only, not on the old revision.
Okay.
Because it is implemented last November exam and this March exam and July exam.
Okay.
But I think if you attended last August, then you have followed 571 2011. 575, I think that is 2013 or 14. Okay, you have to follow this. I think this edition have been sent by soft copy, right?
Yes.
Yes, we have to follow this one only, not the old one. Because there are many changes, particularly in 652 and 570, 575 also there are a lot of changes. Actually, 571, there is not much change.
Okay.
571 only a small changes are there, but they change the, it is in alphabetic order now. The 2011 was not in alphabetic order. The damage mechanisms are in different orders in 2011.
Yes.
Okay, you have to follow this. That's why we send you soft copies.
Okay. Okay.
Okay, right.
Thanks.
Very okay. What I show you. Okay, right. Now I want to show you. LRUT. Okay, this is piping. Everywhere it is similar only. Piping, long range, ultrasound or guided wave testing.
Problem tomorrow's solution delivered today. TWI's long-range technology. Who needs long-range ultrasound guided wave inspection technology? For the shorts, just about anyone involved with the inspection and integrity.
It's not scary for us, sir.
Particularly pipes and tubing.
Not sharing?
No, sir.
Onshore.
Okay, you'll share it. I am replaying.
Yesterday's problem, tomorrow's solution, delivered today. TWI's long-range ultrasound technology. What's it do? Who needs long-range ultrasonic guided wave inspection technology? Well, the short answer is just about anyone involved with the inspection and integrity of longitudinal components, particularly pipes and tubules, onshore and off, chemical plant, oil and gas risers, jetty lines, bridge tubulars, offshore topside pipe. In other words, it's long, it's tubular, carries fluids or gases, and is safety and environment critical. Then it's a job for long-range inspection using ultrasonic guided waves. The evolution of long-range ultrasonic testing is indeed a fascinating one. In the 90s, it looked something like this. The hardware has changed considerably in the last decade, and huge advances have been made in enhancing its performance. But the principles of long-range ultrasonic testing remain the same. In the laboratory, the factory, or out in the field. Nowadays, it's dubbed a test focus, and its most recent incarnation looks like this. What are the advantages of using this technique? First, since it's a remote monitoring system, you can inspect lengthy pipes from distant locations, typically 30 meters. Second, you can inspect inaccessible regions like clamped, encased, or buried pipe. The process provides full volume coverage and is sensitive to metal loss down to 9% or more of the pipe wall section, whether it's caused by erosion, corrosion, or, as we see here, in-service damage. This technique has already provided the way forward in many EC collaborative projects. The examination of offshore subsea risers, steel catenary risers and flow lines. Also for the inspection of encased metal pipelines, perhaps they're buried in concrete, water, or coated with insulation. And also for the condition monitoring of offshore structures and similar large engineering assets. So how does long-range ultrasonic technology work? It consists of an inflatable pod, just like this, and a low-frequency flow detector. Remember, its purpose is specifically to survey pipes and pipelines for corrosion, erosion, damage, and sometimes cracking through fatigue. It's an ultrasonic system, but it uses ultrasonic frequencies much lower than those used for conventional ultrasonics. The transducers, these parts just here, are pressed against the pipe and operate at several tens of kilohertz, as opposed to megahertz frequencies used in conventional ultrasonic testing. So a special flaw detector is required. That's what this box does here. The low frequency sound can travel long distances along the pipe, several hundreds of meters under ideal conditions. So by transmitting the sound a long distance, we can examine large lengths of pipe in one go. We can modify the transducer color and test.
Okay. Now, what is the advantage of it? The advantage is generally for conventional UT insulation removal everywhere to seed the probe. LRUT, only the location where you are putting a collar, that area only insulation to be removed. Other areas insulation removal is required. Okay, that is a major advantage of LRUT. Yeah, no room to remove insulation everywhere. Where we can use LRUT, it is a, for example, piping, underground piping we can use, cross-country pipeline we can use. It is following the guided wave. Guided wave is called a lamp waves in ultrasonic. That waves we are using. That's why guided wave testing, LRUT, they are using low frequency. Generally, normal UT we are using high frequency. We will use two, but here in LRUT they will use low frequency because we want to check the long distance at one shot. In one shot it can travel up to 100 feet. And if, but any branches, any breaks, it will come back. Okay, this is about the LRUT. Okay. So